Exercise 3.7, the bisection method. Let's consider part of a polynomial shown in blue here. A root or a solution is here at C. That is where the polynomial cuts through the x-axis. Y and f of x are equal to 0. Notice that as I move away from here, on either side, the graph will be negative and positive, always. So either side of the solution, I'm going to get a negative or a positive. Let's consider the substitution of a into f of x. It produces a negative. The substitution of b into the polynomial produces a positive. What I can do to estimate where c is work my way along either side and reduce the interval here, ensuring that as I reduce the interval, one of the answers I get, or the substitutions I get, is positive and the other is negative. Let's take a look at what I mean by this. You can read that information there. Here we go. We've got a cubic. We know that there is a solution over the interval 4 to 8. We need to provide an answer corrected to decimal places. So I begin, and what I can do on my CAS, and I'll show you the CAS steps later, is define the function f of x equals x cubed minus 6x squared take away 33. And now what I can do is evaluate what f of 4 is and f of 8. F of 4 equals negative 65, which is a negative number, and f of 8 produces 95, which is a positive number. So because I've got a negative and a positive, then obviously somewhere between 4 and 8, the function cuts through the x-axis, and that will be the solution to this particular equation. So I know that the solution, or the root, lies in the interval 4 to 8. So the first thing I'm going to do is halve that interval and see when I substitute that into f of x if it's positive or negative. So the half will be 4 plus 8 on 2, which is f of 6, and that produces negative 33, which is negative. So now I've got a choice. Either the root is going to lie between 4 and 6, or it's going to lie between 6 and 8. Now, f of 4 gives a negative, and f of 6 also gives a negative. So the solution isn't going to lie there. I want a mix. I want a negative and a positive. Now f of 6 is a negative, but f of 8 is a positive. So now what I can say with confidence is that the solution lies between the interval 6 and 8. And that's what I'm saying. Alright, so I know it lies between 6 and 8. The next thing I'm going to do is explore halfway between that. So f of 6 plus 8 on 2, which of course is f of 7, that produces 16. This is positive. So again, I can have my solution can lie between 7 and 8, but we know that f of 8 produces a positive and f of 7 is a positive, so that's not going to be the case. Instead, the solution must lie between 6 and 7 because f of 6 produces a negative and f of 7 produces a positive. So I can say with confidence that it lies between 6 and 7. And I keep on repeating this process, reducing the size of the interval and looking at what a mix between a positive and a negative at all times. So now f of 6.5 produces a negative. So I want a mix between negative and positive. So I can say now that I've got 6.5 to 7 because 6.5 produces a negative and 7 produces a positive. Now let's halve the interval again and explore f of 6.75. That produces a positive. So now what I can say is that the solution lies between 6.5 and 6.75. The reason being is that 6.5 produces a negative and 6.75 produces a positive, so a mix. Continue on this process as you can see. I'm doing the same thing repeated again and again, making sure there's a mix between negatives and positives, and eventually I arrive to conclude that the solution for this is approximately equal to 6.73. You can see there that I'm getting closer and closer each time. And in the last one, I end up with that answer there. So f of 6.73 is approximately equal to 0.064, so I can conclude this in the very end. Problem 2, I'm after the third approximation of the root for this cubic over the interval between 0 and 4. Again, on my CAS, I would define the function. I would then evaluate the two endpoints for my interval. So f of 0 gives me 2, which is positive. F of 4 gives me negative 42, which is negative. So I know that there is a solution, i.e. root between 0 and 4. Here's my first approximation, which will be halfway of this interval. 0 plus 4 on 2, which is f of 2. This is my first approximation. So 2 is my first approximation. When I substitute 2 in the polynomial, I get negative. So what I know now is that my solution lies between 0 and 2, because 0 produces a positive and 2 produces a negative. So it lies in here. Let's now take a look at my second approximation. So I consider this interval, halfway between it is f of 1. F of 1 produces negative 12, so of course that's negative. So now what I can say is that the root lies between 0 and 1. My second approximation is 1, x equaling 1. My third approximation is going to be halfway between 0 and 1. I do that, and it's a half. So the answer for this question is x equaling a half, because that is my third approximation. Out of interest, this produces a negative. Okay, so halfway between, I've got 0. That there, if I have the substitution of 0 into it, then I know that it's going to be negative. And 1 is going to be negative as well. Sorry, 0 is positive and 1 is negative. Now, if I evaluate what halfway is, so f of a half, I produce a negative. So I know it's going to be between 0 and a half if I keep on going further. But to answer this question, what is the third approximation? It's a half. So let's now take a look at how we generate this with the CAS. So begin, let's define f of x. So menu, actions define. And we've got f of x equals the cubic x to the power of 3 minus 4x squared minus 11x plus 2. It's defined. Looking back at the problem, there's my cubic, and I'm interested in what is positive and negative. So f of 0, I know that it produces a positive, and f of 4 produces a negative, but how did I do it? So it's just f of 0 gives me a positive, f of 4 produces that negative. So positive and negative, so I know that the root lies between the two. What I did next was just went halfway of that interval, so f of 2, and I've got negative 28. So what I can now know is that because f of 0 is positive and f of 2 is negative, then the solution must lie between 0 and 2. So I'm going to explore halfway of that. So obviously f of 1. F of 1 gives me negative 12. So because that's negative and f of 0 is positive, then the solution lies between 0 and 1. And I can keep on going with this. So let's look at f of a half. And you can see here that it's negative. All right, I've got a negative answer overall. And so because this is negative and f of 0 is positive, I know that my solution lies between 0.5 and 0. Halfway of that. F of 0.25. Again, negative. So f of 0 is positive, f of 0.25 is negative, so I know it's halfway between that. And I can continue on. Not that it's required for this question. Alright, so now that's positive. So what I'm able to tell now is that because f of 0.125 is positive and f of 0.25 is negative, then what I can say is that my solution lies between 0.125 and 0.25. So that is an eighth and a quarter. And I can keep on producing that until I get more exact. However, the question only requires us to approximate the third approximation for this. And the third approximation is x equaling a half. But that's how we can use our CAS to work all of this stuff out quite efficiently.